got 10 first place. Eugene got 10 second place. So on third, fourth, fifth votes. And then the first thing we're asked is for the total votes that were cast. So I would assume we would add these up, but I feel like I'm missing something here. So let me take a look at this in a little bit more detail. So so Adam's got 10 first place votes, 4 second place votes, and 3 second place votes. Okay, so I think you almost have to do it by like person to figure out how many votes there were. Does that at all sound familiar to you?
Yeah.
Okay. I'm not sure, honestly. I really haven't, it comes up once or twice a semester. So let's look up voting methods, majority, candidate, example. I found a pretty good reference last time we were doing this. See if I can find it again here. All right. Do you have any notes to help kind of spur this along here? Any way to sort of
Yes, let me see.
I'm looking up some other things here on the other screen. So we can for sure say that the total votes cast is this 10 plus 6 plus 4 plus 3 plus 2.
Uh-huh.
All right, and that adds up to 25. So for a majority, you need the middle point plus 1, right? You need 13 total for a majority.
Okay.
All right, so the first thing is we now have to say, okay, for the plurality method, and we got to know what that is, which I couldn't tell you without looking it up. So it says in the plurality method, the choice with the most first preference votes is declared the winner, and the others follow. So Adams has 10 first place votes, but I think the issue is that it's not a majority. No. 7, 2, that's 9, 13. Okay. So for the plurality method, we look at, for example, Adams. He has 10. Benedict is 6 plus 3. We're just looking at the first row there. And so that's 9. And then Charles is 4. And I'm sorry, Benedict had 2 more. Sorry, I missed that last one. So it's 9 plus 2, that's 11. So Benedict is the winner of the plurality method.
Okay.
So plurality, you simply look at the first row. And I mean, I don't know what to do if there's a tie. We can do that another time if we need to. There's also plurality with elimination, which we're not doing. So we'll just go with that. So the next one is are they a majority candidate? Basically, they're asking like, is 11 enough to get a majority? And the answer is no, they are not. It's not 13. So that's, yeah, that's no good. I mean, in terms of like, if you wanted a majority candidate, you don't get that, but you do get a plurality candidate.
Okay.
Next, we can do the borda count method, which is a little bit easier to explain because
Mhm.
it does actually, this one is one that does come up quite a bit. All right, so I'm gonna just snip that table in one more time. All right, so for the borda count method, you have to label the columns here. I'm gonna just try to find something I could read that says why we're doing this, but the borda count method, there's a, you start at the bottom, the fifth place is worth 1, then you give more for fourth place, third, second, and first. So if you had fewer rows, that you would still start at 1. And then you essentially multiply 5 times 10, that's 50. 4 times 10 is 40. Let me make those a little bit more to the side so we can read them. 50, 40, 30, 20, 10. And then you do the same thing here. So 30, 24, 18, 12, and 6. And then 20, 16. So I'm just multiplying the row and column. You see that they're going down by the same amount each time. So
Mhm.
15, 12, 9, 6, 3. And then for Benedict, we got 10, 8, 6, 4, 2. Okay. Now that you have all of those, you add them up. You add up, like for atoms for A, you find all the A's. So that would be, and I would recommend going like vertically each time. So atom, because it's only going to appear once in each column. Atom is 50 plus 12 plus 16 plus 12 plus 8.
Mhm.
So that's 20, 70, 28 is 98. B is 10 plus 30 plus 4 plus 15 plus 10. So 40, 50, 65, 69. And do the same thing for C. I'm just going in alphabetical order, by the way. If you're wondering why I skipped E and D, or Eugene and Dylan. C is 20 plus 18 plus 20 plus 6 plus 6. So we got 12, 30, 50, 70. That's good. D is 30 from the first column, 6, 8, 9, and 4. He might be our big loser here. And not the game show. 36, 44, 48, 57. And then E, one more here. 40 plus 24 plus 12 plus 3 plus 2. 64, 76, 75, 77. So you're just looking for the biggest number with the borda count method.
Is that letter E?
A was 98.
Oh, 98. Okay.
Unless I added up wrong, which is possible. So I'm pretty tired. So it is possible. Okay. We can now do the plurality with elimination, if you would like.
Okay.
That's letter F. I mean, I don't know how many of these we need to go through, but all right. So I'm going to grab the table again. All right. So really quickly here, I got to find a reference for this plurality with elimination. thought we had done this last time. So I think I know that I've got one here. Okay, so we look at how many first place votes that each person received. And we kind of already did that. We know that Adams got 10, but Benedict got 6 plus 3 plus 2, that's 11. Okay.
Mm-hmm.
So that's the first thing to do. So we eliminate the candidate with the least amount of first place votes and redistribute their votes among the other candidates. Okay, so this Charles, he's out. So his 4 votes goes to Adams. Like this 4 gets split between Adams and Benedict. Okay, so once we do that, we look to see if they then have a majority. So Adams, I guess I should start backwards. Let's maybe just start over. It's Adams has 10, Benedict had 6 plus 3 plus 2, which is 11, and Charles had 4. So the fact that Charles had 4, he's out. Okay. If there
Mm-hmm.
was someone else in the list, they would be out as well. Their votes get distributed to the other 2 guys. So now A has 10 plus 2, and B has 11 plus 2, which is 13. And if at any time they, if at any time you have a majority, which is the case here, 13, then you win.
Okay.
So because Charles's votes get equally distributed to Adams and Benedict now has a majority 13. So it would be better to do an example where there was like multiple people eliminated kind of each time, but I can look for an example, or we can just go on to the next type.
If we could do just one more example, that would be great.
Here, I will look for that now. Right, so here we go. Let me I found one here that looks okay. All right, here we go. So you're just focusing on row 1, okay? But you first have to calculate the number of votes. 14 plus 10 plus 8 plus 4 plus 1, 24, 32, 36, 37. So for a majority would be 19. Okay, so what you'll notice here is that A has 14, B has 4, C has 10 plus 1, which is 11, and B has 8. So the
Okay.
lowest one is gone. You say, okay, that's gone. And they split their votes among everyone else. So it's a little hard to split 4 among 3, but it would be 1 1/3.
Okay.
All right. So this wasn't a great example, but you can see that they are eliminated here as a majority. All right. Sorry, I just need to double check this. Eliminate candidate B. And we bring up there. This is with elimination. Okay, I messed this up. This doesn't read well. Eliminate the candidate with least amount of first place votes. Redistribute their votes among the other candidates. Okay, I apologize. We need to redo this because this is not right.
Okay.
This is why I don't like these props. They're not as clear as I would say would be. So you don't redistribute their votes. You push up, like you push up the next person into that position.
Mhm.
So the redistribute's not the right word here. So Adams, it's Charles is gone, but Adams now is got 4 more votes. So this is incorrect here. Adams now has 10 plus the 4, which is 14. And Benedict still has the 6 plus the 3 plus the 2, which is 11. So let me try to explain this better in this other example here. Okay, so this B person is eliminated right here. And then this D gets pushed up to right there.
Mhm.
And then the C gets pushed up there and so on. All right, so now your new calculation is, okay, A was 14, but we're going to add the D. The D is now plus 4, which is 12. But still, we don't have a majority. So the one with the lowest number of votes, which is C, they get knocked out, and then B gets brought up, and then D gets brought up. So you have a B in this position and a D in this position. So you have to redo the calculation again now. A is 14, B is 10, but D this time is 8 plus 4 plus 1, which is 13. You still don't have a majority. Okay. Which means that the one with the least, which is B this time, it's gone. And now you're bringing this D up here. And that looks like it'll do it because you can see there's a bunch of D's in that. B now becomes 10 plus 8 plus 4 plus 1, which will do it. All right, let's try another one because I really probably made that confusing by not explaining it correctly.
Okay.
All right. So we look at row 1, here, M, C, and S. All right, so M is 3 plus 1, which is 4. C is 4 plus 1, which is 5, and S is 9. And we wonder if anybody has a majority. 3 plus 1 is 4, plus 4 is 8, plus 1 is 9, 18. But we need 10 for majority. Since you don't have that, all the M's are gone. And the way they actually show it is they cross all the M's out like that, which maybe is probably a better thing to do. And then they actually remake the table. But if you're okay with it, we can just sneak up the letters into, that's a C, that's an S, and the other ones are not affected. Okay, so
Okay.
now round 2, you've got C's and you've got S's. C is 3 plus 4 plus 1. S is 1 plus 9.
Mhm.
So 3 plus 4 is 7. Plus 1 is 8, but 1 plus 9 is 10. 10 is a majority. You got it. Okay. Hopefully that is sufficient. I can find another problem if you would like. I wonder if this.
I think it's okay.
Actually, I found where your instructor got these problems from.
Oh,
Drop that in the chat here in case you want to look at that later. Okay. Okay, do we need to do the pairwise comparison method? That would be the last voting method, it appears.
yes.
Okay, let's do it. Pairwise comparison method. Okay. I need to look this up real quick. I don't remember what it is. Pairwise comparison. Compare each candidate to the other candidates in one-on-one matchups. Okay, so that's relatively straightforward. Let me just snip that in. Okay, so we compare them one-on-one. Okay, so it's let me just double check how they do this. Grade 12. Okay, so I believe I can properly explain this now. Let me go grab this one more time. Okay, so you start with, and I'm just going to pick atoms, A versus E. Okay. So in the first column here, since atoms is above Eugene, atoms gets the 10 points.
Mhm.
Then in the second column, you look for Eugene and Adams. Since Eugene is above Adams, Eugene gets the 6 points. In the third column, Adams is above Eugene, so it gets the 4 points. In the third column, Adams is above Eugene, so it gets the 3 points. And then Adams is above Eugene, so it gets the 2 points. So your winner is Adam. And because A was the winner, we got to write A, B, C, and D, and E. They get 1 point. Now you might do like Adams versus Dylan,
Mhm.
but you have to do all the comparisons. So this one's quite long, but hopefully you're going to get the idea here in a moment. So Adams versus Dylan, same thing. Adams is above Dylan, so that's 10. Adams is above Dylan, so he gets the 6. Adams is above Dylan, so he gets the 4. Adams is above Dylan, so he gets the 3. And he's above Dylan in the last one here, so Adam wins again. So now let's do Adams versus Charles. So again, Adams gets the 10 from the first column because he's above it. In the second one, Charles gets the 6. In the third one, Charles wins, so he gets the 4. They're not tied. In the third one, Adams is above Charles, so he gets the 3. And then in the last one here, Adams is above Charles, so he gets the 2. So again, Adams wins.
Okay.
So you would continue this and you have to do all the comparisons. So there's actually quite a few to do. You got to do all of these. Then you got to do like E versus D and E versus C and E versus B, and then D versus C and D versus B and C versus B. I mean, it's not as
Okay.
bad as you think, but it's not, I mean, there's like 20 comparisons to do. So do you want us to keep going with this, or is that sufficient?
I think that's good enough.
Okay. I can also find a simpler one if you want to do it all the way.
I think this makes sense for now.
Okay. All right. So if we go back to your test here, kind of versus quiz thing, it says weighted voting. Weighted voting.
Mhm.
What do you think that means? I'm not sure at the moment.
I can find a worksheet on it.
So I found an example here, but you also have one in your notes
Mhm.
from what you sent here.
I think I might have sent a picture.
You did. I mean, it's in the weird language the instructor uses.
Yeah.
These are not standard terms. Atavistic, pulchritude, mendacious, mendicant. Okay, these are, I don't even know what these are, but these are, I guess they want you to weighted list. Okay, great. So they tell you that it has to be a 2/3 majority, which is important. So you do need to know that. You need to know the randomly assigned words in one round, and then the second round, the entire group makes a decision using the weighted voting system. How many letters were in their word? That's really weird. Okay. So you're just counting the number of letters, and that provides the weight. And you make a weight based on the rule here, like whatever the majority is. So we could make our own up, I suppose. Maybe that would be easier to do.
Okay.
Okay. So golf, swimming, Julia, Matthew, and we need another one here. Let's go Jack. Okay.
Okay.
So let's count the letters here. We got 4, 5, 8, 7, and 4. Okay. And let's say we need a 3/5 majority.
Okay.
Okay. So when it says to create a weight, okay, it looks like you start with a curly brace and you add these all up first. And then you take a fraction here of this. So 4 + 8 + 5 + 7 + 4 ends up being 28. 12, 17, yeah, 28. But we need 3/5 of that. So 3/5 of 28, should have picked it. Ends up being 16.8. So we'll say 17. Okay, so the 3/5 of 28. And then you write it looks like you write the weights next to it. So 4, 8, 5, 7, 4.
Okay.
Okay. And then the second thing it asks for here is well, how many to make a decision? Well, we just answered that. We need 17. So the question is like, then they might ask you some scenarios. They might say, well, does golf, Julia, and Jack have enough to make a decision? 4 + 5 + 4. No, it's not enough. But does, for example, Julia, swimming, and Jack have enough? Yes, because it's this weight.
Does it have to be that exact weight?
It's got to be that or bigger.
Oh, okay.
And I didn't really look at the 2/3 of in your problem where it had 2/3 of 88, which looks like it rounded down. I don't know why you rounded down. You might want to ask that. Why is this rounded down? I don't know. I would think for majority, you'd want to round up to be sure.
Yeah.
Okay. Any more discussion on this, or do you feel like this is good enough?
Yeah, I think it's good enough. It's making sense.
Okay. All right, so the next thing is this whole Euler's circuit, Hamilton circuit
Yeah.
path. It looks like you just have a couple of examples. Maybe they're on another sheet. Oh no, well, you got them there. Okay. Do you guys differentiate between paths and circuits, or to talk about one or the other?
Um, we talked about how there was a difference between the two.
Okay, so you actually are talking about them.
Yeah.
Okay, there's a very succinct definition here. All right, so an Euler path is a path that uses every edge of a graph exactly once. And an Euler circuit is a circuit that uses every edge of a graph exactly once. An Euler path starts and ends at different vertices. The circuit starts and ends at the same vertex. All right, so you sometimes see these. They're like, can you draw something that touches one time, or starts and stops at one time, one place, or can you there's also this one where they have these sort of these rivers with bridges, and it's like, how many bridges do you need to make sure you can always get back home if one, you can only go over it one time? Did you talk about anything like that?
Um, a little bit, but not much.
Okay, trying to find some problems here to make this make sense. I mean, do you know have any idea if you're going to be drawing something, or just saying like yes or no, it is something?
I'm pretty sure it's just gonna um you're gonna say if it's like a path or a circuit, because that's all the practice we've been doing in class.
Okay. So they're kind of problems like this, where it says, let me actually snip in the instructions here. So, can you trace this design without lifting your pencil and without retracing any edge? Is stuff like this?
Yes.
Okay. So are you guys counting vertices?
Yes.
Okay. So there's 5 vertices in this problem. What does that tell you, if anything?
5 vertices. I'm trying- I don't really remember.
Well, I know it's hard, but can you trace this? Can you go, okay, go there, 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 and now what? Right? Like you're kind of stuck.
Yeah, I don't think you can trace it without.
Okay. So now let's look at one that I believe you can here. Just looking at this one here. So this one has 1, 2, 3, 4, 5, 6 vertices. So you start somewhere. I mean, it really depends on how you visualize this stuff.
Mhm.
But see how you can start and stop it and get back to the same place. This has 6 vertices.
Mhm.
That one's better, right? You can get there.
Yeah.
Okay, let me see if I can find some better problems. I mean, this is not really covered in any high school class I've ever seen. It's only been covered in college, which not sure why you guys are getting this, but I'm trying not to find any that are so complicated we can't do them.
Okay.
There's also, I guess I forgot to mention this. There's also when you get to a vertex, you're supposed to specify the number of sort of paths,
Yeah.
and that also helps you to make a decision on this.
Mhm.
Let me see if I can snip this in. I'm sorry. I'm trying to find some. These are all really complicated for what we're doing. Um, uh, About to go back to your problems. I think that you had a couple there. All right, let's take a look at these. These aren't too bad. Okay, so here's a problem. I hope it's helpful here.
Okay.
All right, so we're looking at this, and it's already been labeled for the number of vertices. I want you to see if you think you can trace a path.
You can, it's a circuit.
Okay, very good. So that's important. Where did you start? Did you start down at the bottom, the right? Where did you go? Tell me.
I started at the very top and I went straight down and then I went up and to the right.
And then just like this.
Yes.
Notice you get back where you started.
Mhm.
Okay, so that's good. Um, how about and if we count 1, 2, 3, 1, 2, 3, 4, 5, 6 vertices, that's also important. How about let me grab one more here. How about this one?
Um, no.
Okay,
It,
so we agree the one on the left is a circuit. On the right, though, what if I start here? I should have probably indicated the path. Okay, if you start here, go down, come back,
oh, okay, yeah.
but we don't start where we finish, so that's a path.
Yeah.
And again, they get way too complicated. Sorry, trying to find one more here. Um, Here's one more to look at. This probably isn't too bad. This might be too complicated. I'm not sure.
Is this one a path?
So where did you start? Help me out with that, the top.
I'm trying to
This
think.
one's, I know it's hard without, having it in front of you. It's, so let's just start up here. Like, let's say you go all the way down. Okay. Problem is you get somewhere and you get kind of cornered. So that didn't work. So let's start here. Let's go like down. And so you're kind of cornered again. Like even if you go up, you're not going to get to where you need to go.
Mhm.
You need like, and I don't know if this is, I don't know if you guys talked about this, but if you need like one more basically, because then you can get there. You can come down. Oops, that's not the right one. I want to use the highlighter. You can start, come down. What did I do here? Like this, like this, like this. You come down and then you can loop around
Oh,
and get
yeah.
back, right? But you have to add something to be able to get there.
Mhm.
Let me look at the ones that you have here. Maybe we can talk about those because they're more likely to give you one like you're seeing in your class there. All right. Is this a line here or not? Do you think it was erased on purpose?
Um, yes, I think so.
So let's do the same thing. Let's just trace. We go doom, boom, and then if you start working your way around, okay, that's not good because we need to do something different. We can kind of crisscross here. So that's not good. So this has no path and no circuit. So this is probably why this one was chosen, because you can't do it. You just you sit there and you try and you're like, nope, that's not going to work. You just can't get back there.
Mhm.
But then an 8 vertex figure with one path, I guess these get harder here to figure out and draw. So do you remember what your progression was here with this one? Like, was it you cut across, boom, like that?
Yeah, I'm pretty sure.
But notice that you can't get back where you started.
Yeah.
And that's one of the challenges. So I'm not sure how this, I hope this is one of those where you just have to sort of figure out whether it is or it isn't,
Mhm.
instead of having to draw it. Drawing them is a lot harder, but I think you can do it. A 10 vertex figure with a circuit. Okay. So I think you start, like, one of the things you might start noticing is sort of patterns here. I'll just kind of leave you with this, is like, if you're going to go there and you want to get back, you start figuring out, what does it take for you to get back to where you started? And if you need to go out further, you know, how does that work? Can you go out further or not? Well, you almost have to cut down on that. You have to keep building the same sort of shape each time, triangle. I don't know. That's kind of my final thought for you is, you know, seeing that what it takes to return to the same place is typically some, you know, and if you wanted to add to it, you need to be able to get back to the same place.
Okay.
So if you know, if you like something like this, you can always get back to this. Like you always kind of look at work. How do I get back to the same place? Is the key, and it's typically these squares and triangles that you'll see.
Okay.
All right, we do unfortunately have to stop here, although